All right, now we're going to look at the inverse of what we just did. So before we were solving equations by taking square roots. So what we want to take away from this is that when we raise a number to a power, it is the inverse or opposite of taking the root of that number. For example, squaring a number is the inverse of taking the square root of that number. I'll show you what I mean by that. So here I have solve for r. So I need r, not the square root of r. Now, I know this is a square root symbol, and I know that there is an imaginary 2 as the index because there is no number greater than 2 that's written. So what I would do to solve this is I would raise both sides of the equation to the second power. And when I do that, what I end up with is r is equal to 361. Likewise here, solve for k. I raise both sides to the second power, and k, because the square root of k times the square root of k is the square root of k squared, which is just k. And this would equal, let's see, 0.81. Here, we're doing the same thing, just squaring both sides, and we've got 81 is equal to u. Now here, what we want to do is get this radical alone. So the first thing I'm going to do is I'm going to add 10 to both sides of the equation, and that is leaving me with the square root of t is equal to 15. Now I can square both sides of the equation, and that gives me t is equal to 225. We're doing the same thing, so we're just squaring both sides. Now when I square this, again, remember a square or the exponent of 2 undoes this radical or square root sign. So all I have to do is write what's under the square root sign. So I've got -1 plus x is equal to 64. Then I just solve for x as I normally would. So x is equal to 65. Here again, we're solving. So we're squaring, and we've got 81 is equal to, be careful here. You might be tempted to just say this is r, but no, it's not. This exponent cancels this root out, or it eliminates it. So we still have -r under that was under the radical. So we divide both sides by -1. R therefore is -81. Now on this one, I'm going to go ahead and just move this number before I start squaring things. So I'm going to subtract 17 from both sides of the equation. And I've got the square root of y minus 50 is now equal to 26 minus 17 is 9. So now I can square both sides. And I've got y minus 50 is equal to 81. Well, then I'm going to add 50 to both sides of the equation. And I've got y is equal to 131. Now, if you are ever in doubt, you really can check these. So if I did 131 minus 50, I would get 81, right? So, and the square root of 81 would be 9. So you can check these simply by substituting whatever you said that the answer was. Here, now this one seems a little bit more involved, but we're just going to undo everything around the radical. So the first thing I'm going to do is get rid of the 18 by subtracting from both sides of the equation. And I'm left with -3 multiplied by 17 plus d under the radical sign equals -30. Then I'm going to get rid of the -3 that's being multiplied by dividing by -3 on both sides of the equation. And that leaves me with the square root of 17 plus d is equal to 10. Square both sides. And I get 17 plus d is equal to 100. We'll subtract 17 from both sides of the equation. And D is equal to 83. Over here, again, we just square both sides. So I've got negative 2D is equal to negative D plus 5. And we're just going to solve. So I'm going to add D to both sides of the equation. And I've got negative D is equal to 5. Well, I don't want negative D, so let's divide both sides by negative 1, and D is equal to negative 5. So that is how you actually solve for a variable when it's under a radical. You go ahead and try your turn, and I'll be back. Alright, so here are the integral we will turn. If you have any questions at all, please don't hesitate to ask.